Hello, class. This will be our second video over section 5.6. So this one is specifically for scientific notation. So this follows from our previous video for the exponent rules. And as I mentioned in that video, this topic is specifically at the request of chemistry instructors. Scientific notation is something used in pretty much all science classes, but our biggest single group of students here on campus are going on to chemistry for their science class. Um, Particularly if you're like in allied health, that's a huge group of our chemistry students. And so chemistry instructors requested that we do some review of this topic and a couple others. And so this is for all you chemistry folks. All right. So I am continuing on the 5.6 outline. So there's one handout for both the exponents and the scientific notation. So this was the one that we were working on last video. And so if you go over to page 3, we get into the scientific notation. Okay. Now, before we get into that, just real quick, one thing that we need to review is, or two things. One is the product rule. So if you have the same base multiplied, we're adding the exponents. We're going to do some division too. So if you are dividing a variable or a base, you subtract the exponents. And particularly important for scientific notation is if you have a negative exponent, you're flipping it and basically doing 1 over. So that's going to be important. All right. So scientific notation. And that's section 5.1. That is from an old book. We are in 5.6. The purpose of scientific notation is it gives us a shorthand to write really large numbers. And by large numbers, I mean bigger than 1, or a shorthand for really small decimal numbers. So we're not dealing with negative numbers here, just small decimal numbers that are like small, less than 0, or really large numbers bigger than 1. The general notation is we have one decimal number, or sorry, one number before the decimal. Then we may have several decimal places. I don't know why it says 10 to the y, because we always use 10 to the n. That's far more common. Some books may use y, but n is more common. All right, so what we're going to do with scientific notation, one is we need to know how to go from scientific notation to standard numbers, or sometimes we'll call those decimal numbers, and vice versa. So sort of like with mixed numbers and improper fractions, you have to be able to convert back and forth. We're doing the same idea with scientific notation and regular notation. And then the other part of this, which is really where chemistry students often struggle, is doing operations with them, specifically multiplying and dividing. All right. And so big picture, this n is a measure of how many places we're going to move the decimal when we're converting back and forth. Now, a lot of books, like MATLAB and as well, I think they have you like try to memorize. Well, in this instance, I'm going to move the decimal to the right. This instance, I'm going to move it to the left. But the problem is when you're converting back and forth, you're always moving the decimal point, and it's exactly opposite if we're dealing with large numbers versus small decimal numbers. So you could try to memorize like 4 different instances, but to me, that's the hard way to do it. I think it makes more sense for scientific notation to actually use your common sense, which you don't often get to do in math, but this is definitely an area where common sense applies. Okay, so and I'll give you the key and then I'll explain it. So if we're dealing with large numbers bigger than 1, that exponent is going to be positive. And if you're talking about moving, okay, so large numbers, it's positive. Dealing with small negative numbers, decimal numbers less than 0, our exponent is going to be negative. And so if you can remember that large numbers have positive exponents, decimal numbers have negative exponents, then you can basically use your common sense to figure out which way you're moving the decimal. Okay, so let me explain why that is. I think I already tossed the other example. So if you watch the earlier video for exponent rules, one of the problems we did had an answer of 8 to the 12th. And then when you do that in the calculator, I don't remember all the decimals on this one. 8 to the 12th is 6.8719. Don't care about all the decimals, times 10 to the 10th. So this is standard scientific notation. We have one number to the left of the zero. We have some decimals here, and then times 10, in this case, to the 10th. Okay. So, my question on this, is this a large number or is this a small decimal number? Well, when you multiply 8 by itself a bunch of times, we're going to get a large number, not a decimal number. And so why is this a large number? Well, what does 10 to the 10th mean? Well, it means 10 times itself, 10 times. And if you remember the shortcut for power to 10, that's 10 divided, or 1 followed by 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that is, what is that? The thousands, millions, billions. So 10 to the 10th is 10 billion. So what this is saying, this is 6.87 times 10 billion. That's like 68, almost 69 billion is what this answer means. So this is what I would talk about by saying that scientific notation is a shorthand for writing big numbers or small decimal numbers. And so if you have a big number, you want to multiply by a bunch of zero, 10,000, 100,000, 1,000, 10 billion. So you want to multiply by 1 followed by a bunch of zeros. So you need that exponent to be positive. What happens if you have a negative exponent? Let's say we just have like 5.3 times 10 to the negative 4. Okay. What does that mean? Okay. Well, I've said since we have a negative exponent, that that's going to be a decimal number. Why is that a decimal number? Well, let's explore what 10 to the negative 4 means. So how do we write that? Goes back to our negative exponent rule. So remember, when we have a negative exponent, what that means is we're going to have to flip that number and then make the exponent positive. So if we have 10 to the negative 4, that really means 1 over 10 to the 4th. Now, what does 10 to the 4th mean? Well, it's 1 followed by 4 zeros. That's 1 over 10,000. So that's 1/10,000th. So what is that as a decimal? Well, you can either do it in your calculator, or if you use place values, the tenths, hundreds, thousands, 10,000ths. So 3 zeros and 1. Double check right quick, yeah. All right, so when you're doing large exponents or positive exponents power of 10, then that tells you how many zeros you have. If you're doing negative exponents with powers of 10, it tells me how many decimal places. So we have 3 zeros, but then that 1 is the 4th decimal place. All right, so what this means, this is 5.3 times a small decimal number. So what is that? So that is 0.3053. So we have a small decimal number, which means we have negative exponent. So that's where I say, that's what I want you to memorize. So that way you know how to move the decimal. Okay, so how does that help us move the decimal? Well, let's see what these problems are asking us. Okay, so we're going to start by, this is what we call decimal or standard form. So we're going to write the number in scientific notation. All right, so for scientific notation, first part is the decimal part of it. So the decimal always goes to the right of the first non-zero digit. So 3 is that first non-zero digit. So 3,127, we're going to say 3.127 times 10. Now what power? Well, you get the power by how many places you move the decimal. So where was the decimal in 3,127? It was right here. So how many places did we move the decimal? Well, doesn't matter which direction you go, we did 3 places. So either 1, 2, 3, 1, 2, 3. But the decimal got moved 3 places. So is this a positive 3 or a negative 3? Well, this is not a small decimal number less than 0, but it's a positive because 10 to the third is 1,000. So we're doing 3.12 times 1,000 to get to 3,000. Okay. What are you going to do with 33? 86,000. We want that in scientific notation. First of all, where does the decimal go? Well, it goes to the right of the first non-zero number. So it goes to the right of the 8. So between the 8 and 6, the 8.6. We don't need all those extra zeros because those, now that they're in decimal form, those are basically trailing zeros. Kind of talked about this with rounding. We don't need all of those. So 8.6 times 10 to what power? Well, our decimal started there. So how many places do we move it? 1, 2, 3. Is that a positive 4 or negative 4? It is a positive 4 because we're dealing with a large number. So 8.6 times 10 to the 4th. All right, so now we have a small decimal number. So where does the decimal point go? Always goes to the right of the first non-zero number. So it goes between the first 3 and the 1. So 3.13 times 10 to what power? Well, how many places did we move the decimal? 1, 2, 3, 4. Is this positive 4 or negative 4? Well, now we're dealing with decimals. So decimals have negative exponents. The reason it has a negative exponent is because that 10 to the negative 4th means 0.0001. So that's how we're getting all our decimals. All right, so go ahead and do the next couple, and then we'll compare answers and then go from there. And if you only have like this was just 2 million even, not 2,100,000, just put 2.0, or you could just put 2. That would be acceptable. Most math apps are really picky. I would accept it on a test. All right. So for that point, 4 is 0.6273. We 6.273 times 10 to the negative 5th. And for the 2,100,000, I'm getting 2.1 times 10 to the 6th. All right. Now you might be thinking, well, those aren't too big. Those numbers will fit in the calculator. Yeah, I'm getting ready to give you a sort of example once we start going the other way. All right, so this is starting in decimal or standard form, and we went to scientific notation. Now let's go backwards. I'm going to back up and do 38 and 39. All right, so right number is decimal or standard form, 6.91 times 10 to the 4th. All right, so first thing you need to do is figure out, is this a large number or a small decimal number? The exponent is positive, so that means we have a large number. Okay? So it tells us we're going to move the decimal 4 places. Which direction do we need to move the decimal to get a large number? Well, if we move it to the left, we're getting a small decimal number, so we need to move to the right 4 places. So this is where you gotta be careful. So we got 691. Where's the decimal go? Well, we're started here. Now we're gonna move 4 places. So 1, 2. Now we need to move it 2 more places. And so what we do, and this is why I do the little waves, is everywhere there's a little wave and something missing, we got to put in zeros. So 6.191 times 10 to the 4th is 69,100. You don't have to have the decimals, or sorry, the commas. MATLAB probably prefers it without it, but I think it makes it much easier to read if we got the commas. All right, so what about the next one? 1.16 times 10 to the negative fourth. So is that a large number or a small decimal number? Well, negative exponent means decimal number. So we're going to have to move this decimal 4 places. To get a decimal number, now we're moving to the left. So we start here, and there's 1, 2, 3, 4. So now we're missing 3 places, so we need 3 zeros to the right of the decimal. And you don't have to have a 0 in front. To me, it makes it easier to read my numbers. So 0.00, 3 zeros, 116. All right, so go ahead and see what you can do with the next two. And then I'm going to throw a chemistry number at you. Okay, so 5.705 times 10 to the negative 6. Negative exponent means we have a small decimal number, so we're moving the decimal to the left. And we got to move it 6 places. So the first place puts it in front of the 5. Then we need to move it 5 more places. So we end up adding 1, 2, 3, 4, 5 zeros before we get to the decimal. And then on the next one, 5.587 times 10 to the 6. That's a large number, so the decimal has to move to the right. So getting it to the 7 is 3 places. So we need to move it 3 more places. So we need 3 zeros. So that would be 5,587,000 for that one. All right. So you wanna see a number that really makes scientific notation worthwhile. So in chemistry, there's something called Avogadro's number. And I don't remember all the decimals, but the important part of it is 6.02 times 10 to the 23rd. So give me that number in standard or decimal notation. Well, we know we're dealing with a large number. We move to the right. So there is 2 places. Now we got to move it 21 more. So we need 21 zeros. 3, 6, 7, 8, 10, 14, 15, 16, 17, 18, 19, 20, 21. All right. Okay. Now I'm not gonna lie. I'm not for sure my number name is this big. Thousands, millions, billions, trillions. I think it's quadrillions and then quintillions. And then 6 would be septillions. Yeah, so this is the sort of reason why we have scientific notation. The other thing I want to point out for those of you with graphing calculators, scientific calculators typically have, they do scientific notation, like when we did 8 to the 12th. It said times 10. And on the calculator itself, it has a times 10 to the end button, which will be handy in our next couple examples. If you're doing a graphing calculator, what you would see is instead of that times 10 to the 10, you would see e to the 10. Sorry. Or maybe it's been a while. Could be E and then not 10. Yeah, that's what it is. It's not as an exponent, it's just E10. So if you see E with a number after it, that is scientific notation on your graphing calculators. And to be honest, I don't know where that E comes from, and I'm sure there's a reason. Nobody's ever asked me, so I've never actually had to look it up. But that's scientific notation on your graphing calculators for those of you using graphing calculators instead of scientific. Okay, so that is converting. Now let's go back up here. There's a couple of messier ones. So 671.667, convert that to scientific notation. So what do you do when there's like all these other numbers that we were converting? They were whole numbers, 3,127, 86,000. There was decimals here, but there was it was in the right spot, I guess would say. So on all our numbers that were bigger, they were whole numbers with no decimals. So how do you convert a number to scientific notation that has decimals like in the middle of it? Well, there's a couple ways to think about it, but I think over the years, I think the easiest explanation I have on this is ignore the decimal part initially. So don't even look at that 0.667. What would 671 be in scientific notation? Well, the decimal, so you go to the right, the first non-zero number, so it's going to be 6.71. And then this is going to, how many places do we move the decimal? Well, it would be 2 places, and it's going to be a positive number because we're dealing with a number bigger than 1. What do you do with the 667? I actually just tack it on at the end. So it's going to be 6.71667 times 10 to the second. So I think that's the easiest way to convert this, is just kind of ignore the decimal initially. That decimal part will be just still part of the decimal part. So when I look at that 518, it's going to be 5.18 times 10 to what power? Well, this is kind of boring because it's 2 decimal places again, so it'd be 10 to the second. And then what do you do with that 0.5? You just tack it on. All right, so let's talk about multiplying and dividing scientific notation. All right. So here's the problems we're dealing with. So we have 2 numbers in scientific notation. We're multiplying, 2 that are, we're dividing. It could have negative exponents. So this is a sort of thing that in chemistry, when you're doing some of your operations, this will pop up. And so that's why we're talking about this. And the other thing you have to, just for the math lab aspect of this, is sometimes they want the answer in scientific notation, sometimes they want it in standard notation. So in the end, make sure you're reading the instructions so you know which form they want it. Again, I think the most equivalent example of this is improper fractions versus mixed numbers. You always have to pay attention. If they mention mixed numbers, they want the answer in mixed numbers. So again, just when you get to the end, see which version they want. All right, so there are multiple ways to do this problem, these problems. So I would suggest that you kind of practice more than one way to see which way works best for you. Theoretically, you could do it in the calculator all at once, but this is like the bigger order of operation problems. Yeah, it's easier to put these in incorrectly. Maybe, so let's look and see how to do these. All right, so let's start with 45. So we're doing 6 times 10 to the third times 3 times 10 squared. And we're going to put this answer in scientific notation. Which psi naught is going to be my abbreviation for scientific notation. All right. So I've worked with a lot of students over the years, and so I've been trying to figure out, like what works best for them. And so there's really kind of 2 ways. One, we kind of do the math and understand what we're doing and use the calculator a little bit. Or 2, we kind of completely give up and just totally use the calculator. You can get answers that way, but being a teacher, I'm not going to endorse it. But sometimes, sometimes we have to use the calculators more than math teachers prefer. So I'm going to show you both ways and kind of let you kind of, figure out on your own. So my first recommendation is convert these. So convert each number to standard notation first, do the operation, and then if you need scientific notation, go back to scientific notation. This is sort of like with mixed numbers. If you're doing operations with mixed numbers, you convert it to improper fractions first, do the operation, and then convert back. Same idea. Okay. All right. So what is 6 times 10 to the third? Well, it's 6. And now we got to move the decimal. That's a large number, so we got to move it 3 places. So 1, 2, 3. So that is 6,000. 3 times 10 to the second is 3. And then we're going to move the decimal 2 places to the right. That would be 300. Okay. So now you just do 6,000 times 300. So you get 1 8 and 4 zeros, which is 180,000. So if they wanted the answer in standard form, we'd be done. But if they wanted scientific notation, now we have to convert it back. So the decimal goes to the right of the 1, so it's 1.8 times 10 to what power? Well, we're dealing with a large number, so it's a positive exponent, and we're moving the decimal 1, 2, 3, 4, 5 places. 1.8 times 10 to the 5th. All right. So this is for most students, I think this tends to be the more straightforward way, particularly if you want to not ride totally on the calculator. Okay, so convert it to standard form, multiply or divide, and then go from there. Now, another way that you could do it, it's 10 to the third squared. Okay. This is a non-calculator method as well. So it may not, this is for maybe the mathier, maybe more the geekier answer. So when you have 6 times 10 to the third, 3 times 10 to the second, those tens are bases just like x's. So you could really do the 6 times the 3 and 10 to the third times 10 to the second. So just like that was, this is sort of equivalent to 6x. I don't use y, so the x's don't get mixed up. Okay, so this is equivalent to like 6y to the third times 3y squared. So we can do 6 times 3 and then y cubed times y squared. That's kind of what I'm doing here. Okay. Well, that's 18. And then what do we do when we multiply the base? We add the exponents. So that's 10 to the 5th. Okay. But here's the problem. That's not in scientific notation, and it's actually not in standard form either. It's sort of in between. All right, so this is sort of like getting a mixed number as an improper fraction, and you got to play with it. Okay, so what you have to do is you have to deal with this 18, with that in scientific notation. Okay, so 18 is 1.8 times 10. We'll move the decimal in 1 place, so 10 to the first. Times 10 to the 5th now. And so now we have 1.8. And now for the tens, we're multiplying 10 to the first times 10 to the 5th. So you add the exponents. It'll be 1.8 times 10 to the 6th. Why am I not getting the same answer on both of these? Can you tell me what I'm doing wrong on this? Clearly, I'm doing something wrong, so I'm not getting the right answer. So this is one reason why we tend to avoid this. What am I doing wrong? All right, bear with me. See, this is, this is where as a math teacher, when I make a mistake, I don't just automatically assume that I don't know what I'm doing. I try to figure out like what's going on. Where I know where a lot of you are math anxious, your first reaction is naturally to just want to like think I don't know what I'm doing and kind of get frustrated. So, um, oh, up here. See, that's the other thing, problem with scientific notation with these big numbers is even though I had it written down right, notice that when I redid the problem, I got 5 zeros. So I didn't catch myself earlier. Um, oh, see, there you go. That's why I missed the problem the first time because I typed in 600 times 300. Okay. So I didn't do this on purpose, but I'm glad I did because this is a very common mistake with this type of problem is you kind of know what you're doing, but you're putting the calculator wrong. Okay. All right. So what that does is I added an extra zero. So that's times 10 to the sixth. If any of you had that to begin with, I would say you should have told me, but I wouldn't have heard you. So I'm glad I did it the other way to catch the mistake. All right. But do you see what I mean of like this? Yes, this works, but because of this part of it, where you have to convert that to scientific notation, to me, like I'm a math geek and I mean, yes, I can do this. This is probably the more mathier way, but it's probably the least preferred of the three methods. So just be aware that we can treat those 10 times 10 to some power and do the product rule. Right? It still works. Okay. How about doing this pure calculating? Again, this is not my preferred method, but it's an option. I know it's going to get used, so let's make sure you can do it correctly. So how are you going to put this in the calculator? Okay. And again, every calculator is a little bit different. And so first of all, use parentheses. You know, like the parentheses aren't always the problem. Like in the multiplication problems, they are usually. They don't have to be. But in the division problems, you notice they're not. If you don't put parentheses on that division problem, I guarantee you're going to get it wrong. Right. So I'll come back and do that one and show you what I mean. But put parentheses around each of these numbers. So how do we do 6 times 10 to the 3? Well, if you notice, I think I pointed this out before, right there in the middle, there is a times 10 to the n button. So 6 times 10 to the n, and then put the exponent. Now, here's where you have to be careful because if you just close the parentheses, notice the parentheses is up in the exponent. If you continue with this, we're going to get a syntax error specifically. Okay. Okay, so what we have to do is, well, first of all, you can always delete. If you put the cursor on there on what do you want to delete, and delete, it will delete it. And so what you have to do is once you get that exponent, use your cursor and get a big cursor, the arrow key, get a big cursor. Now you can do your close parentheses. Okay, and then you do open parentheses, and it's 3 times 10 to the second. So we do times 10 to the 2. Again, cursor over to close out your parentheses. Actually, you probably skip that last step, but it's good practice. And then hit enter. Now notice it gives you the standard form. That's 1 8 and then 1 2 3 4 5 zeros. So it gets us right back to what we had before. But we're using the times 10 to the n button. All right. So at this point, see, I kind of like not the teacher in me says I'm going to keep going with the calculator stuff, but this is kind of what I would prefer if you're, try this, converting it over first. If you're having issues, then make sure you can put in your calculator, but note that both ways you're going to have a standard form and you're going to convert to scientific notation. So you're still doing some conversion in here, which I'm happy with as a teacher. Now, I'm going to show you the cheat button. But the problem with cheat button is if you don't want scientific notation, you gotta know how to undo it. All right, so most calculators have a mode button up here, and this one is up along the top. So if you notice that second line says normal, scientific, and engineering. So I'm going to cursor down, go over to scientific. Notice that it's blinking on scientific. I hit enter. So if I move the cursor, now you can see scientific is highlighted. To get out of mode, do second quit. Now I still have that answer in there, so let me just hit enter. And so notice that it gives me in scientific notation. Or if I just typed it in from the beginning this way, but in scientific mode, it would go straight to scientific mode or scientific notation. The problem with this is the only time this semester we're doing scientific notation is when we're doing scientific notation problems. So what are you going to do if you put your calculator in scientific notation mode, and then here in a bit, you're trying to, I don't know, you're trying to solve an equation and you're trying to do 56 divided by 7. It's going to give you scientific notation, right? And so if you're going to change that mode to scientific notation to bypass doing this skill, you got to know how to convert your calculator back, because I'm going to give you, if you ask me, I'm going to give you a little bit, I'll help you, but I'll give you a little bit of a hard time. But if you want to go back to normal mode, put your cursor so it's flashing on normal, hit enter. Notice now that normal is highlighted. So now when you quit, do second quit. Now if we do, your operations will be back to normal mode. That's why I say you could potentially use your calculator for the entire thing. I recommend, like I said, if conversion is a little bit messy for you, do the operation on the calculator, but know that you're still going to have to do the conversion at some point. Okay, so that's a multiply problem. Let's do a division problem. All right, so, and let's do one with a negative exponent. Gonna save time. So we're gonna do 48. So that's 3.6 times 10 to the negative 7th over 3 times 10 to the negative 3rd. All right, so we're gonna do this to convert it first and do the operations, and then we'll do it in the calculator. I'm going to kind of skip the middle operation of like doing the quotient rule on this, because that again, that's for us math geeks. If you want to do it that way, that would make me happy as a teacher, but you don't have to. All right, so what is 3.6 times 10 to the negative 7th? Well, negative exponent means a decimal number. So we are moving the decimal to the left, this case, 7 places. 1 place puts it in front of the 3, then we got to move it 6 more places. So that is 0 point and then 6 zeros. 3, 5, 6, 3, 6. 3 times 10 to the negative 3. Notice there is no extra number here, it's just a 3, but we're still going to move the decimal 1 place, and then we need to move it 2 more. So that means we need 2 zeros and then a 3. All right. Guess what the most common mistake on a problem like this is? Well, that's what I did on the first one, and I didn't get enough zeros in there. So be very careful when you're putting this in the calculator. All right, so we got to have 1, 2, 3, 4, 5, 6 zeros in the top. 6. Is that 3, 6 divided by, and then 0.2 zeros, 3. All right, so now we have 0 point and then 3 zeros and a 12. 1, 2, 3, 12. So again, if MATLAB says put the answer in standard or decimal form, we're done. If they want scientific notation, now we got to put it in scientific notation. So the decimal goes to the right of the 1, so it's going to be 1.2. It's going to be a negative exponent because we're doing a small decimal number. And what is the exponent? 1, 2, 3, 4. So negative 4. All right. So let's do this in the calculator, see what happens. I'm gonna, I don't know where it's coming from. All right. Um, so let's type it in. Let's see. I haven't used the fraction button on this one before. I'm going to experiment. I'm going to use the fraction button. I'm used to using a divide. Oh, I'm going to come back to that. So let's do this without the fraction button first. So we have 3.6 times 10. So times 10 to the n of -7. And make sure you're using the negative button, not your subtract button. And then notice the cursor still up on top. So move your cursor with the arrow keys and then divide by. And then we want to divide by 3 times 10 to the -3. So 3 times 10 to the -3. 1.2 times 10 to the -10. All right, so notice that we got a very different answer because this is supposed to be 1.2 times 10 to the -4. All right, so why are we getting completely different answers? Well, answer comes back to order of operations. Okay. So if you look at what's typed in the calculator, we got 3.6 times 10 to the -7 divided by 3 times 10 to the -3. So what is the calculator going to do? Well, calculator follows order of operations, and so it's going to do 3.6 times 10 to the -7. It's going to divide by 3. It's going to get an answer, and then times 10 to the -3. So since the calculator is following exactly what you typed in, it's multiplying by 10 to the -3, but we're supposed to be dividing by 10 to the -3. This is why parentheses are crucial. All right, so I'll show you two ways to deal with this. So let's redo this. So now put parentheses, 3.6 times 10 to the -7. Cursor over, you get big parentheses, and then divide by 3 times 10 to the -3. Cursor over. So that gives us our 0.001230. So that's what we had before. That's our 1.2 times 10 to the -4th. Okay. Right. So parentheses matter, right? So in the division problems, they're not going to be there. You have to know to put parentheses around the top, put parentheses around the bottom. Well, what about the fraction button that I mentioned earlier? Okay, so with the fraction button, let's type it in without parentheses. And then cursor down to get to the denominator. Oh, so it gave us the right answer without parentheses that time. Why is that? Because the calculator is following order of operations. It's doing the top and the bottom like a grouping symbol and doing the division last. Okay, so that's why it doesn't need parentheses because they're already built into a division, like a fraction problem. Division button just says I'm going to divide by the next thing, and it doesn't know you need parentheses around it unless you put parentheses there. All right. And I would feel, like I said, as a math teacher, I'd prefer you do this by hand. But again, the real reason we're doing this is to prep you for chemistry. And so in chemistry, they're not as concerned about doing everything by hand. They want the right answers for this sort of stuff because they're worried. They have chemistry on their mind. They want you to get the chemistry right. And so the numbers are just part of that. So that's why I'm showing you this on the calculator as well. All right. And we're not going to deal with adding, subtracting with scientific notation. And the reason being, that comes back to like terms. Because when you're subtracting, you have to have the same terms. And so then you're dealing with like different exponents. So you can't treat, you know, that messes stuff up if you're trying to deal with the exponent rules. But if you're trying to add subtract with scientific notation, well, you really what you do is you just convert them to the actual numbers, and then you just add or subtract the actual numbers. Okay. So again, that's what I would do if I was adding subtracting, and then we don't have to deal with all the exponents. And, it's the multiplying and dividing where most of the mistakes happen in chemistry. It it's not. I mean, it's. I haven't had chemistry in a while, but I'm pretty sure it's rare where you're adding, subtracting scientific notation numbers compared to multiplying and dividing. All right. So hopefully this helps, and again, we'll have this on the test for us because that's part of our curriculum. But this is one of those topics looking forward for next semester, or for any science class you may ever take. Physics classes have big and small numbers. If you're taking astronomy, we have huge numbers in astronomy. So this is applicable in a lot of science classes. All right, that's all I have. Have a good day.